Ladies and gentlemen, welcome back. Next, please welcome Mr. Roy Cheung, Customer Solutions Architect, Infrastructure Modernization, Google Cloud, to the stage.
Hey, good morning, everyone. Good afternoon, everyone. Hope you enjoyed the day. Hope you enjoyed this morning section. Hope you enjoyed the lunch. Hope you save some energy for this afternoon section. Just a friendly reminder, if you want a napping room, it's on the other side. This is exciting room. Today, you won't be surprised. The whole event is talking about all the topics is all around AI and machine learning. Let me unpack this. This world right now is buzzing with AI and machine learning nowadays. With the new model, incredible capabilities, it feels like the future is arriving daily. But behind all these excitements, we all needed to think about the fundamental challenges for the actual fundamental challenges for these excitements is actually how to get those hands-on and efficiently using those incredibly hardware under the hood. Just like one of very famous local commercial chips, someone did ask, what is the most crucial thing for hot pot? Literally, it's the pot itself. For the AI ML, the most important thing is the infrastructure, the GPU and the TPU. Those are the very incredible but hard to source limited resources. So it's always harder to get those enough capacity for your training and inference workload. At the same time, once you get them, the other challenges is how can you use it in a wise way? How can you optimize them? It's always a question in between how to balance cost and performance. One more thing is like the resources fragmentation. Every workloads, every trainings, actually with the various workload, they will have different hardware needs. They will have different requirement on the physical location. It makes the whole questions become more complicated. So what is the traditional way to balance the cost and stability? Generally speaking, we just trying to pick size, whether we're going to use the standard instance or the spot instance. With the standard instance, is predictable, is guaranteed resources, guaranteed predictable performance. The only drawback is it's not able to fix the risk of hardware stock out. Looking at the other side, if we're going to use the spot VM, is another way to go. It gives you a very promising discount with 60 to 91%. It's much cheaper, it's best for the stainless fault tolerance workloads, especially for those testing scenarios. But it also can be preempted with something like 30 seconds warning. Well, for those AI workloads, second is not acceptable. Generally speaking, those AI workloads are often very sensitive to be disrupted. So to tackle this, Google nowadays, we're trying to provide something called optimizability toolkits with the GKE platform to help your life easier to manage this kind of resources. Let me break down into the different components. The first one is talking about the resources reservations. More or less, it's like we've got two different offers. The first one is on-demand reservation. Most of you should already heard about this. You reserve the resources, you get the guarantee capacity, you can use it. It's all predictable. It's for those enterprise capacity, enterprise use case, large-scale critical applications. But sometimes you might not, your need might not be immediate. You might want to have those resources in the future. Like in the next week, starting from next week, we needed those training materials. But I don't want to hold all the resources lying down starting from now till the next week. So it comes in future reservations. So the future reservation, just say you book a table in advance, you make the reservation for the resources, and it will trying to allocate and secure the resources for you. Most importantly, it comes with the two new features. The first one is talk about the recommender for the most available capacity for your request. The other one is the dense co-location compute resources. So that's important. So let me firstly go into the calendar mode for the recommendation. So here is an example. If you're trying to ask for A3 Ultra GPU machine in the US Central One, once you make that reservation, it already gave you, it will do the counting and the forecasting underneath. It will give you the recommendation. So say we can foresee US Central One, you can have these resources at 3rd to 10th of June, or US Central 1B, you can have it at the 4th to 11th. So you can look forward and pick the most suitable time schedule for your workloads. And the dense co-location, it gives you a better choice. So all the the distributed training, distributed inference workloads can be more closer. So it can have your training tasks finished faster. So it's crucial for those AI training workload as well. So this table just gives you a high-level idea what's the different options you can use for those future reservation. Right. But if those use cases, I don't really need those 24x7 availability for those capacity. I just need a small little time frame, but it's also in the future. I don't really have a tight timeline. I just need those resources to run my training. Here comes with DWS, the dynamic workload scheduler. I think some of you already heard it. So it has two different modes. One is a fast start, but more importantly, it also comes with the queued provisioning. What does that mean? That means it's not just queuing your usage. Say I just need 3 nodes for 3 hours. It will schedule up until the resources is available. It will run your job. So if the job is not time sensitive, it can wait. You can use it. More importantly, you can also make it a queue. Like I need it for 3 days continuously. It can find a slot, is able to provide you the 3 continuous days capacity and do that reservation for you. So that's the DWS fast start with the queued provisioning. What's new? It comes with the discounted price, and also it simplifies the access with the more efficient resources utilization. Now you can pick a more smaller, more granular options for the GPU machines, so you can use those to schedule your training jobs. So you don't really need to try to break it down and trying to mix up all the training to utilize the resources. Now you can have a granular choice. And also we will have a compute class integration, which I'm going to cover it in the next slide, but it's super important. More importantly, the TPU support is coming soon as well. So the compute class, the custom compute task nowadays is support all the GPU families in Google Cloud right now. This gives you the capability to do the automation on the compute classes. So for the database, you can try to ask for resources to run your job in coming future. Say in a coming month, I want 3 days continuous GPU for my training workloads. At the same time, actually, I can make some fallback plans with the custom compute class. This is an example of cost optimized fallback plan. Say if the ideal case, if I can spin up some spot VM, it will be the most cost-efficient options. But during the time, if I can't really spin up those spot VMs, it will automatically retry with the database fast start option. If it's not available as well, I can also set the on-demand as the fallback plan. So no matter how, is some other options I can provide to make sure my training job will be kickstart within the time frame I'm expecting. All of those you can manage by yourself, but actually now the open source batch job scheduling system is fully integrated with GKE, so you can use it to do those orchestration jobs for you. One more important new feature with the queue it also allowed to optimize the port-to-port communication. So that means it will try to put all the correlated port within the same instant as you can. Same idea as the dense collocation. Trying to make those chaining ports as close as possible to each other, it will help you to increase the whole chaining performance quicker and faster. Right. So here I just talk about all the idea, all the new features coming with the GKE obtainability toolkit. What does that means actually? How can I use it in my daily life? Let us go through some examples. AI training tactics. During the AI training daily life, generally I would say we have 3 different scenarios. The first one is a day one scenarios. Day one scenario, we just got some new idea. We have like a testing workload with a number of GPU nodes. We're trying to kickstart those. Training test scenario. At that case, we don't need a queue because single workload, you don't need the orchestration. You also don't need a long-term reservation because generally in this scenario, you won't have tight deadlines. So that means you are flexible. The training jobs, the POC can be run anytime within the training period. So it's a good scenario to leverage the DWS fast start, especially if you have the requirement to have like 5 days expected continuous computation time. With the queued provisioning is something can help you out to achieve this. So here is the first combination. How can I use those obtainability toolkits for my day one operation needs? Day two is a little bit different. Day one, if you have a distributed training job, feel free to use queue as well. So don't do those orchestration job manually, always trying to find a way to automate it. Day two, slightly different because now we might have some application get approved, starting to up and running. Now we have a larger scale of the GPU farm. At the same time, we started to expect the system availability and reliability. We want a reliable system, so long-term reservation is something good for you. So you can have a long-term reservation to make sure you have your resources to run these, like the production workloads. But during the day two, actually, besides these production workloads, you have some testing, you have some new workloads, you have some R&D is running as well. So actually, it will be a mixed scenario. At day two, you have some application already rolled out to production. At the same time, you have more R&D up and running. R&D relatively is some plenty of smaller, not sensitive workloads. So back to the same tactics, we can use the DWS fast start and the spot VM to utilize those resources. The interesting tactics here, we can use a queue so the R&D workloads can try to leverage all those unused resources from the long-term reservation. As long as the production workload is not using those resources, we just use it for those R&D workloads. Don't waste it, don't idle these variable expensive resources. Day three. Day three always go with a large scale production workloads. Sounds more straightforward. Large scale production workloads, guarantee performance, reliable systems, available systems. Just kick through all them, just use a long-term reservation, it should be fine. But actually in the large scale production, we also needed to cater the different expansions. Say now we are rolling out production, it might be customer facing. That means, first of all, we need to cater the quarter-to-quarter growth. At the same time, we might also need to cater those unexpected spark. Say after a marketing campaign, we may have a lot more data. We need to load up our training system at a period of time. So in that case, actually a combination of this as a layer approach will be much better. So say we have the long-term reservation as a baseline strategy to cater your daily training workloads. At the same time, we can have DWS fast start as a flexible capacity for those quarter-to-quarter organic growth. Last but not least, for those unexpected opportunistic capacities, it's best to leverage spot VMs. It will be the more cost-effective option. At the same time, it will be easier to allocate to cater these kind of scenarios. So here is some high-level idea about the real-life tactics on the AI training. How about AI inference? Actually, AI inference sounds more or less alike, but actually it's not the same as the AI training scenarios, because the actual challenges for AI inference is more on the bursty and unpredictable requests. Just like a chatbot, you can't really predict how many people, how many questions, how many chats will be generated a day for the production scenarios in the inference surfacing. So these spike scenarios, generally, we have two common ways to tackle this. The first one is reserve enough capacity to meet those demands. Obviously, Jordan, I don't need to tell, you already can tell it, just money. As long as you can burn the money, you are okay to have those capacity idling underneath, that's fine, but it's not price-worthy in a production scenario. It's not good for enterprise workload, right? The other way is reserve the base workload. Just only reserve the base and use the on-demand or the spot capacity for the burst workloads. But in that case, sometimes you're taking risk. The scaling speed is not able to catch up your workload spot, or you might also taking a risk. You might have stockout issue during those bursting on demand or spot as well. So these two common ways, actually they have their own problem. So what's the additional GKE obtainability toolkits for inference able to solve them out? Also, DWS flat start. But here we are talking about the other parameters. It's talking about with node recycling. Node recycling is something like you can give some instruction for the GKE to proactively provision the resources before the old one was decommissioned. Give you an example like this. This feature, one of the great things for this feature, you can even select your own lead times. So like the lead time at the top. So actually it's talking about what's the lead time when the first node is going to decommit. For example, if it's a DWS, you just got a 7 days window before the instance going to be decommissioned, but your workload is still serving, you can have this node recycling mechanism. So it will spin up the other node and then do the handover. It will hand over all these requests and serving with node 2 before the node 1 decommission. So the whole game is trying to seamlessly transfer all the workloads from one node to another. In that case, we are able to reduce the interruption on the AI servicing inference service. The other feature I would like to introduce here is a seamless portability in between the TPU and GPU. So actually, it's the same feature I mentioned previous, talking about a custom compute class. But here I would like to highlight there's a new VLLM support of TPU announced this year. So now if you're using the VLLM framework, we have just simply like 1 to 3 line code changes. You can simply point your images from using GPU to TPU or vice versa. So you can now use either the GPU pool or the TPU pool as your fallback plan. So it greatly extends the capability or the possibility for you to leverage different kind of available resources to make sure your workloads is always having some capacity to run through it. So we also have some granular options for our GPU, say the A3. Now the minimum capacity is not 8 GPU. Now you can spin up starting from 1 GPU. So that means simply, literally just give you more flexibility. How can you have a more granular configuration on your hardware resources for the GKE clusters? Right, so same idea. Let's run through some scenario as a real-life tactic. How can I apply those toolkits to help my daily life? So day one still like we are doing the evaluation, we are doing the POC. We just need a small workload or like a single workload. Maybe this time I just want to test out, I'm trying to inference a Llama model, but I would like to test out the performance in between using a GPU or TPU. So in this case, I can leverage the fast start as mentioned with the auto class. At the same time, Spot 3M give you the best price performance. It gave you very promising discounts at first. You don't really need long-term reservation because it's just a testing, and it's not really like a time-sensitive workload. For day two, more or less the same, be honest. For inference, you don't really need to change a lot. The only thing is, for day two, maybe you would like to have a little bit more reliability, and that's why compute class can help you to enhance that part. But still, long-term reservation, personally, I don't really think you need it as a day two inference workloads. But day three, obviously, long-term reservation is important. We need to secure we have sufficient capacity for the base workload. At the same time, we would like to have our nodes is always seamlessly transfer without any interruption to the services. So database fast start with node recycling will be important. A mix of Spot VM can help you to use your resources more efficiently. But if you want to have more guaranteed workload, on demand is the way to go. Last but not least, compute class give you the flexibility to mix and match all these different GPU or TPU types at the back. So give you extra flexibility and also reliability. So here I just went through the live scenario for how can I use the toolkits for the inference or training daily jobs. So after this, the obtainability action plan. Think ahead. How should I use those tools? You need to answer yourself this question first. What type of workload actually you're running? Is it a fine-tuning, training, inference? What was the specific hardware requirements? Is it specific on some GPU or TPU types? What's your budget? What's the trade-off in between the performance and cost? So these are the key questions you need to ask for yourself. Once you have these answers, go through back to the previous scenarios. You will know which toolkit is able to help you out. Right, so here are just two tables. After this, you can check it online. Actually, it gives you high-level idea. These different toolkits, how is the best fits for your training or tuning or inference workload. So for the rest of the time, actually, I would like to introduce one more thing. I just mentioned about the obtainability toolkit, but now, remember our topic is how to manage your GKE workloads for the AI ML. It's a long topic, effortlessly. So how can I try to have a more robust way or more easy way to manage my day three large-scale AI, no matter it's training or inference workload? We introduce Cluster Director here. Okay, Cluster Director. Before I introduce this, we need to know what's the typical challenge nowadays. We all talk about training, inference. We always think like the training jobs is like this. We have more GPU, we have the GPU, we have longer time, it will finish the job, and then the more GPU, the training times will be faster. It will be a linear relationship. In reality, definitely not. In reality, there's a lot of hiccups, especially you have more than one GPU is mixing in the workloads. It will be a lot of unexpected challenges coming up. Say, sometimes some node failure, network failure, fabric failure, checkpoint issue. The job was interrupted, we need to rerun it. Maybe you need to start from the checkpoint or start from the beginning. Some hardware with planned maintenance. All of this will cause you down on the expected line. Actually, this is dragging you down from your time to model, making your jobs unpredictable, making your life harder. More importantly, it jacks up the cost a lot because the GPU is costing you on the running time. And now, with this blue line, you have a lot of these expensive running costs with doing nothing, or actually it's not producing any variable outcomes. And that's the challenge we would like to fix. And here comes the cluster director. So the cluster director is trying to fix these challenges like the compact setup, trying to reduce the uncertainty on the performance, reduce troubleshooting and the downtime. So it mixed with these components. We have a cluster management with easier workload allocation, with the resiliency design, with observability outcome to make your whole GKE cluster more manageable. So here, go through a little bit, demo. So first of all, cluster director, you can simply go through here, enable the API, it will tell you all the dependence API. Once you click through it, enable it, you can kickstart the whole job. It's all easy. It sounds like easy as clicking some buttons, but literally it is. So once you click on the cluster, it has two modes. The first one is if you don't really know what you should go for, we already have some reference architecture. You can go for it. Here are some architecture, one from the Google experts. They already designed it on the typical deployment patterns. You can start from there and make your POC a quicker start. But we know from the customer side, most of the time you may have more unique and custom requirement. So in that case, we give you the flexibility to your cluster. So here, so besides the custom your cluster by yourself, we're trying to simplify the whole process. It's not just infrastructure layer. So when you're trying to install your workloads onto the cluster director, one more interesting feature we would like to introduce is the recipes. We have a recipe hubs for those popular models, say Llama 3, for example. If you put it, trying to deploy it, you will see it will pre-select all those compute resources, all the numbers on top. So it will be the recommended parameters to get the highest performance with the GKE cluster on Google Cloud. So it makes your life easier to just simply go with this recipe. But if you don't like it, as I mentioned, maybe some customer, they already have their own idea, talking about they would like to have higher customization. We make all these options editable. So you can custom yourself on the workload side. So once you have your platform ready, the cluster director, you have your workload ready. More important, it will be the day 2, day 3 observability, the maintenance on day 2, day 3 clustering. So observability actually giving you the single glass of plain to have a quick look through. Like the yellow boxes, it indicate those subspec nodes. Subspec nodes means it might be unhealthy, maybe it's already been a long time, didn't check the healthiness. So you can have a single click to check the healthiness again. For those red one, you can simply have a single click to replace those bad nodes underneath. Even though in the maintenance, you can simply click on it and do the maintenance at the desired time to prevent those unexpected, unplanned maintenance. So here it gave you the simplest way to do this maintenance job and the health checking scenario. So with this, actually the cluster director is able to help you out to reduce the overhead and the waste on your compute resources to the green line to make it more efficient. That is the overall idea. We would like to help you out with the obtainability toolkit for the GKE workloads, with the cluster director on the data management on the large-scale GKE cluster. At last, I just want to quote from Alfred. I want to tell you civilization advantages. We are talking about extending the number of operations we can perform without thinking about them. And that's the whole idea. We're trying to automate as much as possible so you can more focusing on your AI training, AI evaluation. So happy building, everyone. Thanks.
Thank you, Roy. Please scan the QR code on screen to check in and collect your stamp for swag redemption.